we need to know all these terms so that when I'm talking about this, you have this in your back pocket. So natural numbers, if you want, you can write beside it that this is your counting numbers. These are the first numbers you learned when you were like a little kid. Like when you start counting on your fingers, you don't count it with 0, right? You go 1, 2, 3, 4, 5, right? Those are the natural numbers. Whole numbers are the natural numbers plus 0. Okay? Integers, of course, are the whole numbers with positive and negative signs. So it includes 0, but it also includes the negative numbers. Real numbers are all possible numbers that you can basically find, say, in your math career, real numbers. Your calculator uses the real number system. It doesn't use the the complex number system. So have you ever heard of imaginary numbers? Yeah? Okay, so we're not dealing with that in this course. In one of the AP courses, we might touch upon some of the imaginary numbers. But in this course, for all purposes, it all has to do with real numbers. Of course, in the real number system, we have what's called rational and irrational. Rational is any number that can be written as a fraction. It includes terminating decimals, and it includes repeating decimals. Okay, and irrational numbers are the ones that can't be written in fraction form. So I always say it's non-terminating, non-repeating decimals, right? Okay, not a pattern. A pattern doesn't mean it's repeating, right? So the biggest irrational number that comes to mind is what number? Huh? Pi, yes. Pi is a great example of an irrational number. Any other ones that come to mind? Like the square root of 2. That's an irrational number. Is the square root of 4 an irrational number? No, because the square root of 4 is 2, and 2 is a whole number, right? Okay. And of course, we kind of already went over this. Prime numbers are number divisible by 1 in itself. So 2 is the first prime number, right? You need to have this list in your back pocket because that's what we're going to be doing today is we're actually doing something called prime factorization. And composite numbers are numbers, of course, that aren't prime. And I should say not prime, but not 0 or 1 either. So it's not the best definition, but you get what I'm trying to say here. So factoring is writing a number of a product of numbers. The numbers are called factors. I don't know why I have a big space there, but anyways. We are going to find the factors of 40. Okay, so how do we figure this out? We have our divisibility rules, right? So we're going to start with the first factor, which would be 1. And the easiest way to get the other factor is ask yourself, what times 1 gives me 40? Well, that would be 40. So you see I'm having the pairs together so I don't miss any. Okay, so now we're going to go to the next one. 2. I know 2 is divisible. 40 is divisible by 2. Why? It's an even number. So now 2 times what gives me 40? 20. Do you see there's my other pair? So I don't have to test any numbers between 20 and 40 now, right? Okay. Is 3 a factor? No. What was the divisibility rule for 3? Yeah, the sum of the digits has to be divisible by 3. Okay, so 4, of course, is 4 times what? 10. Do you see there's my pair? So again, I don't have to test any between 10 and 20, right? Okay, is 5? Yes, 5 times what? 8. Okay, so there's my pair. Is 6? So what's the divisibility rule for 6 again? It has to be even, which it is, and the sum of the digits has to be divisible by 3, and it isn't. So then if 6 isn't, it's 7. 7 is one of those that you're not going to memorize the divisibility rule for. So that means I've now listed all the factors of 40. How do I know that? Because I've tested all the ones between 5 and 8, and I don't get any more, so I don't have to test the ones between that. Okay, some of the factors are prime numbers. The factors of 40 that are prime numbers are, who can tell me? 2 and 5. The first 10 prime numbers are, okay, so 2, what's after 2? 3, 5, 7, that's 4, 11, 13, 17, 19, how many I have there? 1, 2, 3, 4, 5, 6, 7, 8, 2 more, 23, 29, there you go. Okay, I can say dot, 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 but anyways. Okay, so now this is probably, I don't know, you used to do factor trees and stuff like that, right? So now what we're doing in grade 10 is a thing called prime factorization, which is a listing the number as a product of primes, okay? So the prime factorization for 12. So what you have to do is you need to divide 12 by a prime number, only a prime number, okay? So if I take 12 and divide by, what's the first prime number that you can think of? So start at the bottom, 2, okay? So 2 goes into 12 how many times? 6. Have you seen this rapid division process before? Kind of? Okay, now what is, can I do 2 again? Yeah, because 6 is even, right? And then what do we get? 3. And 3 is prime, so I know I'm done. So I'm going to write 12 as a product of 2 times 2 times 3. There's another way to write this, and it's using exponents. So how could I write this? Anybody? Yeah, 2 to the power 2 times 3. Do you remember that? Okay, so why don't you try 24? So again, start with the lowest prime number and divide. Okay, so 24 is even, so I'm going to divide by 2. I get 12. I'm going to divide by 2. I'm going to get 6. I'm going to divide by 2. I'm going to get 3. So therefore, 24 is 2 to the power 3 times 3. Yes? Okay, any questions there? Okay, moving on. Now we're going to do prime factorization. We're going to do it with a factor tree and repeated division. So, do you remember how to do a factor tree? Okay, so it's honestly, the repeated division is my preference, but I'm going to show both ways. You can do whatever you want. The textbook likes factor trees, but that's fine. So basically, the way factor trees work is just come up with any 2 factors of 36. So just name one, and then we'll get the other. Okay, so I heard 6. So then you split this up as 6 times 6 like this. This is what the factor tree looks like. And then you got to now split up 6 into factors of 6 now. So what times what is? Yeah, 2 times 3. And then this would be 2 times 3. So then this kind of translates down. So there is your prime factorization. So it's a preference. Do you like it this way, or do you like it as repeated division? So remember how I did repeated division? I knew it was divisible by 2. I got 18. I divisible by 2 again. I got 9. Then it was 3 and 3. Do you see I get the same answer? It's just a different way of doing it. Either way, I get that 36 is 2 to the power 2 times 3 to the power 2. Does that make sense? So again, I will try the factor tree again for 100. So what times what is 100? 25 times 4. Okay, so I'm going to put 25 times 4. Again, you keep on doing the factors of the factor tree until you get prime numbers. So what times what is 25? And you don't do 1 times 25. You never use 1s. Yeah, 5 times 5. And then a 4 is 2 times 2. So you can see that this is the prime factorization I'm done because I'm at prime numbers. Again, my preference, and I don't know, what do you think at this point? Do you like repeated division? Do you like the factor? You like both. Okay, so when you're doing your homework tonight, try both and just see what you end up getting. Again, I like dividing by 2. Keep on dividing by 2 until you're done. So that's 50, 2 is 25, and then 5 and 5, right? So therefore, 100 is 2 to the power 2 times 5 to the power 2. Yeah? Which one's so much easier? Repeated division, yeah. Okay, especially when we get big numbers like this, because you probably don't even know what factor, well, I guess you could say 100 times 33 for that one, okay? What factors would you have said for 3,300? You could have said 3, I guess. 100, yeah, if there's 2 zeros, you know it's divisible by 100. So 100 times 33. You guys know the shortcut for timesing by 100, right? Just adding 2 zeros. Make sense? Okay, so then now what is the, what can 100 be split into? Okay, 10 times 10, sure. And then what about 33? 3 times 11. So now I'm done because 3 and 11 are prime. So it's up to you if you want to put them in a box so you know you're done and you don't have to go back, whatever. So then 10 times 10, what would 10s be? Yeah, it's only 2 times 5, right? So therefore, 3,300 is 2 to the power 2 times 3 times 5 to the power 2 times 11. Do you notice I did it in order, right? Okay, just for ease of answer. So if we go back to repeated division, if I do 3,300, now you might argue, well, this might be longer. Repeated division, 2 goes into 3, 1s carry the 1. Do you see how this works? 2 goes into 13, 6 carry the 1. 2 goes into 10, 5, and oh, does everybody see how I did it? I'll do it again. Divide by 2. 2 goes into 16, 8, I don't carry anything. 2 goes into 5, twice, carry the 1. 2 goes into 10. Do you see how I'm reading this? 5. That's actually rapid division, right? If you were truly taught that way. Okay, so now I can't divide by 2 anymore. It ends at the 5. So let's divide by 5. 5 goes into 8. Once, carry the 3. 5 goes into 32. 6, carry the 2. 5 goes into 25. 5. Keep dividing. It ends in a 5, so we're going to divide by 5 again. 5 goes into 16. 3 times. Carry the 1. 5 goes into 15. 3. So what's it divisible by? It's up to you if you wanted to choose the 11 or the 3, but either or you're going to get that as the same thing, right? So what do you think this time if the number's big? Was it easier still to do rapid division? It's a preference, whatever. Okay, so 1250. Do you want to do that one on your own? Okay, I'll give you a second to do that one. So 1250. I'm just going to do rapid division here. So 2 is 6, 2, 5. 5 is 1, 2, 5. 5 is twice 5 and 5. So 1250 is 2 times 5 to the power 4. Yes? Everybody got that? Okay. So now we're going to actually use this to figure out greatest common factor. So you've been doing greatest common factor probably since grade 7. So what's the greatest common factor? Greatest common factor, or what's the abbreviation? GCF is the largest factor shared by 2 or more of the terms. It's the largest number that both terms can be divided by. So there's the grade 7 way of doing it. I'm going to show you it. It's good. It works. But the problem is in grade 10, the numbers are way bigger. So the grade 7 way may not be the greatest way. So the way we did this in grade 7 was we listed all the factors. So 1 and 12. Remember this? 2 and 6. And then 3 and 4. Okay? Easy. 12 is easy factors, right? Factors of 18. 1 and 18. 2 and 9. 3 and 6. 6. And does 4 work? Nope. Does 5 work? Nope. And then we're at 6 again. So do you see how I have it? So now, by definition, this is the largest factor shared by 2 or more of the terms. So you can see visually it's 6, right? That's the biggest one. Of course, 2 is shared and 3 is shared, but that's not the greatest, right? The greatest was 6. Okay? So again, we're going to do this with the grade 7 way, and then right here, I'm going to show you how to do it with prime factorization. So 15 and 30. And some of you probably could tell me what it is already. Does anybody know what it is already? 15. So very similar to, well, basically, that's what it is. The LCD, yeah. So 15 goes into, like if the lower number goes into the higher number, you know that's one of the multiples, right? So anyways, so 1 and 15, 3 and 5, and that's it, hey? So that is 15. And then 30 is 1 and 30, 2 and 15. Remember, I'm trying to do it in the pairs so I don't miss anything. Yeah, so 3 and 10, and then 5 and 6. And then I know I'm done because I reached the pair that's, there's nothing in between. So does everybody see 15 is the GCF? Yes? Okay. So why would it change if we're with negatives here? So I guess my question to you would be, what is the factor that gives you a negative in there? No? Nobody knows? Okay, so if a negative is common to both, then that means your answer has to be a negative with it, because that means you can factor out a negative that's common to both. So it's up to you if you want to deal with the negative later or deal with it now. I don't think I would list the factors of, like I'm not going to list the factors 1 and 24. Or sorry, negative 1 and 24. 1 and negative 24. Do you see what I'm saying? I don't think I would list them twice. What I would use is common sense in the fact that if they're both negative, then that means your GCF has to be negative. Okay? If one is negative and one is positive, then you will not have a GCF negative because it's not common to both. Does that make sense to you? So I would do it the same way. So 24. 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then 5 doesn't work, right? So 48 is 1 and 48, 2 and, again, you probably already know what the GCF is, right? 2 and 24, and you'd say, bingo, it's there. 3 and, does 3 work? What's the divisibility for 3? So you add them together, and that's 12, so you know it's divisible. Yes, so it's 16. Then 4 and 12. 5 doesn't work. 6? Does 6 work? Yeah, 6 times 8, and 7 doesn't work. Okay, so does everybody see we have 24? I didn't actually, I put GCF equals. GCF equals 15 here. Okay, so what's my GCF here again? Minus 24. Do you remember why I said it was minus? Because the minus is part of both. Okay, if this would have been negative 24 and positive 48, then it would have been positive, right? Okay. Does that make sense to you why it would be positive if there's only one of them? Again, I could list the factors, but if, say for instance, 48 was positive, well, I could have a negative and a negative, right? To get a positive, but it's just easier to do it that way. Okay, so determine the GCF of 126 and 144 by checking factors of the smaller number starting with the greatest factor. So I don't even know what they really want here, to be honest. They're basically saying to do it the other way. I want to show you the way to do GCF with prime factorization because I think this by far is the best method. Okay, because A, you could miss. It's easy to miss over here, right? GCF with prime factorization is really easy. Okay, so 126, we're going to divide. What goes into 126? 2. 63. Does 2 go into that? No. What's the next one? 3. So then that goes 21. 3 goes again. And we're 7 and we're done. So I'm going to write it over here. 126 equals 2 times 3 times 3 times 7. Notice I didn't write 3 squared. There's a reason why in a second. 144. I'm going to divide by 2. What do I get? 72. I'm going to divide by 2 again. 2 goes into 7. 3, carry the 1. 36. Is everybody catching on to my rapid division there? Okay, that's even again. I can divide by 2. So I get 1, 8. That's even again. I can divide by 2. It's 9, and 3, and 3. Yes? Okay, underneath it, I'm going to write it as 144 equals 2 times 2 times 2 times, how is it, 4 2s? 2 times 3 times 3. Now, what I'm going to do is I'm going to circle the common prime numbers, okay? I got a 2 that's common. I got a 3 that's common. And I got a 3 that's common. Okay? Does everybody see what I did there? Yes? So guess what my GCF is? One of the commons, which is 2, times one of the commons, which is 3, times the other common, which is 3, which means it is 18. Which when I get to LCM, it's actually different, but it's the same technique with the prime factorization. So we're using prime factorization not to do it this, like I think this way is too cumbersome. It's a lot harder to miss stuff, right? This is the fastest, most easiest way because on your quizzes and tests, they're going to be high numbers. You don't have time to go through all the factors of it. Way faster to just do rapid division, find the common things, multiply, done, right? Okay, so we're going to do that again. GCF of 138 and 198, write the prime factorization. Okay, so 138, it's even, so 2. 60, carry it, 9. Not even anymore. What goes into it? 3. So 23. Was 23 prime? Yes. So we're done. So I'm going to write over here 138 is 2 times 3 times 23. Okay, so now I'm going to do 198. Even, so I can divide by 2. So what do I get? 9 and 9. Yes? Okay, what's a prime number that goes into 99? 3. Remember, don't just divide by any old number. You can't divide by 9, even though it's screaming at you, divide by 9. 9 is not prime, so don't do it. So 3 is 33, then 3 is 11. 11's prime, I'm done. So 198 is 2 times 3 times 3 times 11. Circle the common prime factors. I have a 2, I have a 3, and that's all I got. So what's my GCF? 2 times 3, which is 6. What do you think? Okay? Okay, so now we're going to go into least common multiple, and this is not a stretch after this, after we've done all these. Again, we have the grade 7 way where we do multiples until we find the common one, but it's really, prime factorization is the way to go. So, the LCM of a number are determined by multiplying the number by 1, 2, 3, 4, so on, or skip counting. So for instance, multiples of 12, 12, 24, 36, 48. Do you see what I mean by multiplying by 1, 2, 3, 12 times 1, 12 times 2, 12 times 3, or you can do the skip counting, whatever. Multiples that are the same for two numbers are the common multiples. So again, you've had enough math that you could probably just tell me what the lowest multiple is. What is it? Huh? So now you're confused between GCF and LCM. Multiple means I'm going 4, 8, 12. What would be the lowest? 12, right? So you got to get your terminology going. So again, the grade 7 way was going 4, 8, 12, 16. Do you see I'm going 4 times 1, 4 times 2, 4 times 3, 4 times 4, 20, 24. You see what I'm doing? That's 6, 28, 32, 36. And now I'm going to do multiples of 6. 6, 12. Do you see now I've already found the lowest? That's the least common multiple, right? That's not what it said. It says find the first 3. So 12, 18, then what? 24. Do you see I found another one? Yes? Then 5, it's 30. 6 is 36. Do you see I found the third one? Okay? So this would be the LCM right here because that's the lowest. This is just happens to be other multiples. So back in the day when you're doing fractions, one of the tricks was if the denominators are, such and such and such and such, you could just multiply the two together. That doesn't mean it was the LCD though. For instance, 4 and 6, you could have got 24. You could have got the right answer if you reduced it in the end, but 12 was the actual LCD. Ring a bell? Okay. So the least common multiple, or LCM, is the smallest multiple shared by 2 or more terms. So again, I'm going to show you both ways, but in the end, my preference, should be your preference, is doing the prime factorization. So determine the least common multiple of 15, 20, and 30. Like I said, not my favorite way, but I'm going to list the multiples. 15, then 30, then 45, then 60. I'm going to stop. 20, then 40, then 60. It looks like that might be it, but I got to do 30 now. 30, 60. Do you see? There's my 60. That's my LCM. They all go into 60. Make sense? That's the grade 7 way. I'm going to show you what I think is the better way, the grade 10 way, because it works every single time. Prime factorization. 15 is 3 times 5, right? 20, 2, 2, 5. Yes? 30, even. So it's 2, 15, 3, 5. So now I'm going to list it, my prime factorization. 15 is 3 times 5. 20 is 2 times 2 times 5. 30 is 2 times 3 times 5. Okay, I'm going to let you catch up. Now what we're going to do is like we did with the GCF. Okay? What did we do? Yeah, we circled the common ones here, right? So what is that? The 5. Okay? And then what did we do? Okay, so now here's the difference. We just have to find multiples of each one here. So do you see what I'm saying? I have a 2 that's common and a 3 that's common here. Okay? So what we have to do here is we need to do the common, I say the common times the leftovers here. So if I were to do the GCF, and this is not what the question's asking, my GCF would be, does everybody see? The 5 is the one that's common to both. Okay? It would just be 5. For my LCM, though, you just have to have any common that's common to 2 or more times the leftover. So do you see I have a common 2? I have a common 3. I have a common 5. And I have a leftover 2 here that I'm going to circle in red just so you can see it better. Do you see I have a leftover 2? So what do I get when I multiply that together? 2 times 3 is? Times 5 is? Yeah, I get 60. Same answer I get there. So do you see what I did there? I circled the common. I listed them once. So 5 I listed once. 2 I listed once. 3 I listed once. And anything left over I put back in there. And then I multiply it. So let's try this again. My stacking toy blocks that are 12 centimeters tall next to the blocks that are 18 centimeters tall. What's the shortest height at which the 2 stacks will be the same? So we're going to do it as prime factorization. 12 is 2 times 6, then 2 times 3. So 12 is 2 times 2 times 3. 18 is 2 times 9. Then I have a 3 and a 3. Am I going too fast? Okay, so 18 is 2 times 3 times 3. What do I do again? I circle common. So I'm going to change my color. There's a common. There's a common. Okay, what would my GCF be? 6. Does everybody see my GCF would be 6? And that should make sense to you that 12 and 18, 6 goes into both, right? LCM. LCM would be list the 2 once, list the 3 once, then the leftovers. Doesn't matter which order, it's multiplication, right? So what do I get? You see this is 6 times 6, so it's 36. So at what height is the 2 stacks the same height? 36 centimeters is the first multiple. If you stack a 12, then a 24, then a 36, and then an 18 and a 36, they would stack up the same at 36. Do you see? Okay, so this is something that